Welcome to 4.03. Today we're going to be working on sketching graphs of radical functions and showing the key features of a graph. And before we do that, I want to just review a couple of things from the previous lessons so that we feel pretty comfortable working with exponents and radicals so that when we're graphing them we don't have to worry about those things. All right, so what I want to do is I want to revisit this situation where we are simplifying the square root of 16x squared. So just remember that when we're square rooting something, we're asking what can I multiply by itself to get this argument. So I'm trying to figure out what can I multiply by itself so that I get 16x squared. And so we can go through and we simplify, and we're going to split up the radicals. So we have the square root of 16 times the square root of x squared. And this seems pretty simple, right? The square root of 16, we go, okay, well that's 4. And the square root of x squared, well that's really easy, that's x. And what you're saying here is that 4x, when I multiply it by itself, will give me 16x squared. And it works. Multiply 4x times 4x, you get 4 times 4, which is 16, and x times x, which is x squared. So this is the square root of 16x squared. But we also want to consider that there might be some other answers. So think about the square root of 16. You can multiply 4 by 4, or you could also multiply negative 4 by itself and get 16. So there's actually another possibility, right? I could also have negative 4x, right? If I multiply this by itself, I encourage you to pause the video and try it. Negative 4 times negative 4 gives me 16, and I'm good. Same thing also is true of the square root of x squared. I can multiply x by itself, and I'll get x squared, but I could also multiply negative x by itself and get x squared as well. So this gives me two more possibilities, right? I could have a positive 4 with a negative x, and I could also have a negative 4 with a negative x, right? So I multiply negative 4 times negative x by itself, I'll end up with 16x squared. And this looks really confusing, so let's kind of eliminate the ones that are the same. So notice that negative 4 times negative x, well, that's going to be the exact same thing as 4 times x. So I don't need to worry about this one. And these two here are exactly the same because I have a negative 4 times x and 4 times negative x, and so either way this is going to be negative 4x. And so what I realize is that my options are either I have positive 4x or I have negative 4x. Those are the two possibilities. Okay? And so this would be the correct solution to simplify this equation here. Okay? And what this comes from is that, look, I can multiply, when I'm looking for the square root, I'm multiplying a number by itself. And so if I multiply a positive number by itself, I'm going to get a positive. And if I multiply a negative number by itself, I'm going to get a positive as well. So when I'm looking for a square root, it doesn't matter whether I take the positive or negative version of the root. Now you can of course think, well, if this were the cube root, if I were looking for the cube root, there would be a difference. Because if I take a positive number and multiply by itself 3 times, I'm going to get a positive number. But if I take a negative number and multiply by itself, I will get a negative number. All right, so at this point, go ahead and quickly simplify these on your own. I will post the answers in about 5 seconds so that you can see your work and check it. All right, so let's go ahead and now we're going to move on to thinking about how we would graph radical functions. So we're going to look at the square root of x. And thinking about that's x to the 1/2 power. What will that graph look like? So our goal is going to be to sketch a graph of these basic radical functions here. So square root of x, or I could write it as x to the 1/2. Remember, they mean the same thing. And I want to graph this function, y equals square root of x. So what I want you to do is pause the video. I want you to create your graph, and I want you to imagine that, this were a test, and you had to just kind of come up, use your skills that you have for graphing, and go ahead and create the graph yourself. And look at your graph after you've created it and think about, does this make sense? Okay, does it make sense? Note your y-intercept, note how the graph is changing, and then come back and we'll talk about it and you'll be able to understand it much, much better. Okay, so I hope that went really well. What we're going to do is we're just going to sort of create a table. So remember, it's always a tool to have, great tool to have is to be able to just create a table of x and y values. So x value, and here will be my y value. And remember, y is just the square root of x. Right? So in my head, I'm thinking, okay, this means I'm computing the square root of that number. Okay, and so I can go through and let's just start at at 0. Right? So x is 0. Well, what's the square root of 0? 0. Not too bad. Okay, and let's keep going. So the square root of 1, if x is 1, the square root of 1 is 1. And so be about there. Okay, and then you might say, okay, let's try the square root of 2. So you plug in 2 for x. And you don't know the square root of 2. Your calculator does, and it's approximately 1.4. And so you come over here and to 1.4, you're somewhere there. Okay. And you might realize at this point, look, I don't want to spend my time with Wolfram Alpha. Let's just use x values whose square root we know. So we'll move quickly to 4, and the square root of 4 is, of course, 2. And after 4, we come to 9. Square root of 9 is 3. And then we move on to 16, which is, the square root of 16 is 4. Somewhere around there. And then 25, and the square root of 25 is 5. Okay, so I can now graph my function. Okay. So let's look at some of the key features of this graph. And I'm going to ask you the question. I'm going to give you a couple seconds to think about it. And I want you to have a thought in your mind so that you're actively engaging with this graph here. So the first thing to think about is, okay, what is the y-intercept? Well, the y-intercept is, of course, what's the x value, what's the y value at which it crosses the y-intercept, the y-axis. And so that's going to be at 0, 0. Right, that's a y-intercept. Is this function increasing or decreasing? Well, it's pretty clear that it's increasing, right? As I take bigger and bigger x values, the square root gets bigger and bigger. Okay. And now I want you to think about, is it increasing quickly or slowly? This one's a little harder to think about because we don't have anything to compare it to. But notice that the steepness of the graph, well, it seems to be getting shallower and shallower and shallower, right? And if you were to think about, just a straight line, so imagine you were just graphing a straight line. Well, when your x value, so imagine you're graphing the graph y equals x, right? It's just a straight line. Well, then when you plug in 5, your y value would be 5. And so your line would be just like that, right? And so notice that even a straight line with slope 1 is growing at a much quicker rate than the square root function, okay? All right, so here's what I'm going to do. I'm going to go ahead and I'm going to give you another radical function, slightly different here, and I want you to graph it on your own. So here we go. Let's take a look. So now I want you to try graphing y equals square root of x plus 2. And what I want you to do before you start doing anything, I want you to look at the function. I want you to think about what it will look like. Have a mental picture in your head. Think about what it will look like and why. And then go ahead and use your table to find a couple of values. Okay, I hope that went well. This should be pretty simple, right? Think about it. When you plug in an x value, so say I plug in 0, I'm going to take the square root of that x value, and then I'm going to add 2 to it. No matter what x value I plug in, I'm going to take the square root and add 2. So all the values that I found here, I'm just going to add 2 to each one. Okay? So when I plug in 0, square root of 0 plus 2 is 2. Square root of 1 plus 2 is 3. Square root of 4 plus 2 is 4. Square root of 9 plus 2 is 5. So if I were to go through and graph this function here, when x is 1, I have a value of 3. When x is 4, my function has a value of 4. And when x is 9, my function has a value of 5. Okay, and you can think about it, you keep going, right? When x is 16, has a value of 6. Okay. And so I can see that what happened to my original parent function, right? This is the parent function. It's the most basic of square root functions, right? And, well, every point was increased by 2. So I would say, right, what happened to my parent function to create this new function? Well, I translated it vertically 2 units, right? All right. One more thing that I want to talk about is why didn't we move to the left here? What would happen if I plugged in a negative value? So imagine that I plugged in -2. Okay? I want you to, at this moment, pause the video. I want you to think about what would happen if you plugged in a negative value for x, and then I want you in your comment to include your reason why I can't have any negative x values. Okay? So make sure that's in your comment along with your question or answer to someone else's question. All right, I hope that went well. On the next page, I'm going to give us a couple more to go ahead and graph, so to prepare yourself and get ready, so that tomorrow we can start using these functions, these graphs, to talk about real-life situations. All right, so here are 3 more for us to try and graph. And so what I want you to do before you go in and just start trying to graph it, I want you to look at the function, and I want you to think, what happened to the parent function to make this function? So how did the parent function have to change, and what effect will that have on the graph? Okay, so you're thinking about translations or reflections or whatever it is. And so for each one, I want you to write think about what happened to the parent function in order to make this. So maybe it was translated up or down or something like that. Okay, and so what I want you to do is I want you to try each of these. Okay, and then go ahead and press play again, and I want to talk about a couple things, and there's a specific question that I want you to answer. All right, so the first thing that I want you to do, and I'm going to mention this first, is that for this last function here, in your comment, I want you to write what you think, what the transformation that happened to the parent function. Of course, the parent function is just the parent function y equals square root of x. What happened to the parent function in order to create this function? So how will the graph be a little different? Okay. The next thing I want to talk about is this first one here. So notice that I have the square root of 4x, and I can simplify this because it's the square root of 4 times x. So it's really just 2 times the square root of x minus 1. And you might be asking yourself, okay, why did I not make this plus or minus 2? And the reason I didn't is because when we're graphing, we're usually talking about what's called the principal root. So if I have this square root of 4, and I can say, okay, that's plus or minus 2. Well, the principal root is this positive version here. This is what's called the principal root. Principal root. Okay? So in this case, we're going to simplify it to positive 2. Okay? So good luck with these, and we'll talk about them tomorrow.